Ratio of angle and sides. The ratios can be multiplied or divided, and the given triangles will remain proportionate. The triangle ABC, we have our right angle at vertex C. Side A is 3 inches, indicated here. This is line segment BC. Side B, indicated here, is indicated at 4 inches. That's line segment AC. And then we have side C, 5 inches, located here, and that's indicated by line segment AB. Well, we have a proportion in that the ratio BC over AC, or 3 over 4, what we're going to do, we're going to multiply this by a factor of 2. And in doing so, we want to see what happens to this segment. Does it become proportional? So what we're going to do now, we're going to increase this side by a factor of 2. We're going to increase side BC and side AC, again by a factor of 2. So let's multiply our numerator 3 by 2 and our denominator 4 by 2. And let's see, we have 3 times 2 is equal to 6, and 4 times 2 is equal to 8. And we've indicated that here. So now our new length of the side for B is 8, and the length for side A is now 6. So now we want to see what now is the length of side AB. Well, we can do that using the Pythagorean theorem. And the Pythagorean theorem states that the square of the sides of the two sides of a right triangle is equal to the square of the hypotenuse. So we know A is at 6. So we're just going to plug in the numbers into the formula. A is 6, 6 to the second power, plus B is 8. 8 to the second power is equal to, for the sake of argument, let's say we really don't know what C is right now, but we have 10. But we're going to verify that. C to the second power. Now all we need to do is work out the operations. 6 to the second power, or 6 squared, is 36, plus 8 to the second power is 64, and that would be equal to C squared. Now we have 36 plus 64. We know this is equal to 100. It's equal to C squared. Now to find out what the value of C is, we're going to take the square root of both sides. So let's take the square root of 100 and the square root of C squared. Well, the square root of C squared, that now becomes C. And the square root of 100, we ask ourselves, what number times itself will give us 100? And we know the answer to that is 10. And we can see that 10 is what we have listed here. So we have proven that this is proportional as the sides have grown. Example 2, triangle ABC. We know that side A is 3 inches in our triangle, side B is 4 inches, side C is 5 inches. So what we're going to do is create a ratio, the ratio of side AC over side AB, which can be numerically represented as 4 over 5. So what we're going to do is to multiply both the numerator and the denominator by a factor of 3, a constant factor. 4 times 3 is 12, and 5 times 3 is 15. Okay, since we multiplied all sides by a constant factor of 3, A, which is 3 inches, should then be 9 inches. Well, let's see if that checks out. We can prove the proportionality by checking with the Pythagorean theorem and plugging some numbers. Again, the Pythagorean theorem states that A squared plus B squared is equal to C squared. Okay, A for right now, let's leave blank. So we'll put A squared plus B squared. We have 12, which is B, to the second power, and that's equal to C squared, C being 15 to the second power. All we need to do is some multiplication. We have A squared plus 12 to the second power is 144, and that would be equal to 15 squared, which would be 225. All we need to do is begin to isolate our variable. In this case, we're working with A squared. So what we're going to do is subtract both sides of our equation by 144. Subtract 144 here, subtract 1, 44 here. So we end up with a squared is equal to, and let us subtract, we have a 1, borrow, makes this a 1, 12, 81. A squared is equal to 81. What we need to do now is find the square root of a squared. So the square root of a squared and the square root of 81. The square root of a squared would be equal to a. The square root of 81 would be equal to 9. So we're saying that a is equal to 9, and indeed, that does prove the proportionality of this triangle.
I like to explain the logic of trigonometry. Let's look at this principle on the board. Though the size of similar triangles vary, and notice we have 3 triangles here. This is triangle 1. There's one triangle. There's another triangle here. 2. And there's another triangle here, a large one here. 3. Now, the size of these triangles, they vary. They're different. The angles of these triangles always remain the same. These angles, so this is angle A, obviously, they all have this same angle here, but this angle also, B, is the same as this B angle and as this B angle. And this angle over here, we know that this is 90 degrees. We'll label that as C. There's another 90 here, which is C. And this is 90, which is C. So now these are similar triangles, so all the angles are the same. Now the ratio of any of the 3 sides is always, the ratio now, proportional. So the ratio of these sides are proportional. It is upon this principle that trigonometry functions. And so this explains a little bit the logic, and later on in the course teachers will explain the rules of proportion and upon how trigonometry functions.